So robotics traditionally has been centered around mechanical engineering departments, and robotics has been considered mostly a mechanical design. But since low-cost devices, wireless communications, analog, embedded processing have all come to light, we're able to have an embedded systems experience through robotics. So instead of having robotics as a mechanical device, we can now use it as a device that is centered around embedded systems, which is the center point of ECE. So first, it's incredibly important that we, as a group at ECEDHA, understand the student. And the student interfaces the most with the lab managers, lab professionals, in their environment, how they teach, what they see, how they learn. So adding the lab professionals holistically gives us a really good feel for how industry can adapt our tools to give the student experience the best it can be. And so far, even though it's a new track, we've had good conversations, we've had good insight as to what tools, what products, what technologies will work. And I'm hoping the tracks tomorrow and subsequent conversations are going to really drive a greater understanding of how we, as both academia and industry, can give an ECE student the best experience to choose ECE in the future. So the challenge is that right now mechanical engineering and computer science are very large departments. And traditionally, most universities have a general engineering track their freshman year. And in that track, they find their way around different degrees and choose. And so what's happening is that people are not choosing electrical and computer engineering because what they're being taught as a freshman is biased, or the internals are such that they're choosing other degree types. If we position robotics correctly and make it less about mechanical and more about embedded systems, and we really target the freshmen, we can, I think, not only give incoming engineers a great experience, which is important for an emotional contact for their education, but we can also create an environment where ECE is properly displayed and the benefits of that degree are better understood. And so I believe that the long-term opportunity with the lab professionals driving a great experience with freshmen through robotics will give us an even playing field for degrees coming out of university. So I think it's a great thing to have robotics in high schools. And there are many great programs. First Robotics is being probably the most popular, but Vex Robotics, Best Robotics, and there are many other clubs and many other electives and after-school programs that are centered around robotics. It is the single most popular subject when it comes to STEM education. Without any question, it's the #1 understood and #1 taught item. So I do believe that robotics does drive students to think about engineering itself when they go to college. However, it's very framed in a mechanical structure. It's all about a game that's played or a competition being won, and it's very mechanical intensive. And so what we're trying to offer is a balance. We know that robotics of the future has a blend of mechanical, computer science, and electrical to have a real complete robotic system that works in Factory 4.0 or even autonomous vehicles if you want to go all the way to artificial intelligence and 5G. So what happens is that they're learning about the mechanical structure, how to build a system in high school, and what we're trying to do is say, when you get to that first level engineering experience in university, we want to make sure that you have a balanced view of what is really inside a robotic function. There's mechanical, CS, as well as ECE. And I believe that giving that balanced approach, people will make a better informed decision about what aspect of their education they want to focus on. So mechanical engineering and computer science are fine. They're great degrees. We want more STEM-ready kids in the United States. It's not a bad thing. But what we want balance, because we believe that the electrical part is missing from a lot of these educational opportunities because they're being positioned as a mechanical function or a programming function. Mm-hmm. So I think if we support, universities' outreach and support can drive some of this message down to those big programs and make sure there's balance everywhere. Not only do I think you'll get more kids coming in because now you have something else to offer. Today, you're only offering a coding experience and mechanical experience. And there may be some kids out there that don't like those two things. Or if we are able to get electrical, we might be able to draw in more kids. And I think that's an exciting opportunity. So TI right now is very concentrated on two major technology types. One is analog, and the other is called embedded processing. So approximately 90+% of our revenue comes from these two areas. If you think about a robotic system, what is really all the components inside that make up a large part of its function? First is power management. That's an analog function. Motor drive, motor control, that's an analog function. Sensors, analog function. You have wireless communications, digital function. You have embedded processing, programming, digital function. We have all these pieces inside our portfolio that are the main parts of what a robotic system is. What the opportunity lies is, what do you do with it? How does it impact society? How does it impact business? And so whether it's a robotic arm or an autonomous vehicle, all of these things require a lot of the same technologies that I just mentioned. And that opportunity is where TI is focused on all of our end markets and our R&D, is to drive these end equipments so that each robotic system of the future is continually using TI technology with advanced materials and semiconductors. In closing, I believe that the ECEDHA organization is built to ensure that electrical and computer engineering can impact students. And that impact is going to come from great lab experiences, because our degree has a very large hands-on component. And I'm proud to be a part of the organization that is going to be continually striving to give those students the best experience, make them industry ready, and make them the best engineers we can be.